the chip has 3 different privacy and security mechanisms on it that make any copied or changed chip detectable. I'll explain them. You can, if you can show slide 5, please, picture 5 on security, supported security mechanisms. A chip has 3 really nice features. One is a privacy feature, so you cannot secretly read the chip of an identity document that's, for example, in your wallet, in your physical wallet, or in your bag, because you need access to the so-called machine readable zone, and that's the bottom part of the identity document. You need to see that, because from that you can compute the access code to the chip. So that's in order to be able to read the chip. That's a privacy protection mechanism that's in place. 2 different protocols for that, buck and paste, but anyhow, we support it. That's one step that you can do. So it's not possible to secretly eavesdrop on an identity document in your purse. Second thing is, all the data in the chip is signed. So any bit that is changed in the chip is detected, because it's signed, and it's signed by the country that issued the identity document. In order to be able to verify all this, you need the so-called country signing certificate. We have those country signing certificates of most of the countries in the world that support it. It's about 172 countries worldwide that issue chipped identity documents. Roughly 2/3 to 3/4 of them indeed share their public their country signing certificates with. So that allows you to check any manipulation of the document. And then there's a third protocol that very few technology providers indeed support, and that's so-called clone detection. So in general, anything digital you can copy with, well, bit by bit, 100%. But inside the chip that supports clone detection, there's a secret that you can challenge, again, using that country signing certificate, a complex cryptographic protocol, but you cannot copy. So we can distinguish between the original chip issued by, let's say, the German government, or the Estonian government, or the Dutch government, and the copy. So those 3 mechanisms together imply that if you check all 3 of them with good software, that you're 100% certain that it's the original chip. That still leaves one option from Jens open. You can, of course, replace the data on the document with other data. So you could put your own photo on there. That's possible. Then the outside of the document would look like anybody you would, and you can do that you can do it with Photoshop. You even don't need generative AI for that. You can do that with Photoshop. It's just as easy, but it won't change the quality of the chip. We can also, of course, compare the outside and the inside, and that would be a fraud signal if, for example, somebody glued a different picture on it.